All right, today we're going to crack the code on two of the biggest ideas in all of programming, abstraction and decomposition. Now, these aren't just fancy buzzwords, They are the secret sauce behind how basically all complex software gets made. So let's dive right in.
Have you ever looked at a really complicated app or maybe a massive video game and just thought to yourself, how in the world does someone even begin to build that? I mean, it seems completely impossible, right? But it turns out programmers have a secret weapon. It's all about a specific way of thinking.
And our guide for this lesson actually comes from a kind of interesting place, a GCSE computer science paper. But don't worry, we're not going to treat this like a test. Instead, we're going to use it as a super practical guide to thinking just like a programmer.
Okay, so first things first, let's set the stage. We need to get into the mindset of a programmer who's been given a problem to solve. And this exam paper gives us a classic one, building a system to manage a school's sports day.
So this program has to juggle a whole bunch of data. We're talking student IDs, what year group they're in, their team names, race times, you name it. That is a lot of information to keep track of without making a mess. And buried deep inside this paper, we find this one little question that just gets right to the heart of how a programmer would tackle this whole thing. It's question 9E, and honestly, it's just brilliant.
See, the question flat out tells you that abstraction and decomposition were used. Your job is just to spot how. This is the core challenge we're going to break down and solve together.
So to even begin to answer that, we've got to have the right tools for the job. And in this case, that means really understanding what these two terms actually mean. Think of them as the two most essential tools in any programmer's toolkit.
And here they are side by side. You've got abstraction, which is all about hiding the messy details so you can focus. And then you have decomposition, which is about taking a huge, scary problem and just breaking it into little, easy-to-handle chunks.
Let's look at abstraction a bit closer. Really, it's the art of ignoring stuff you don't need to worry about. The car analogy is just perfect. You don't need to be a mechanic to drive a car, right? You just use the steering wheel and the pedals. The car's creators have hidden or abstracted away all that engine complexity for you.
And then we have decomposition. This is your #1 strategy for not getting totally overwhelmed. You know that feeling with a big school project? You don't just do the project. No way. You break it down. First research, then an outline, then a first draft. Suddenly, it feels doable. That's decomposition. Okay, so we've got our tools, we understand them. Now let's head back to that exam question and put this knowledge to work. We're going to build the kind of answer that gets full marks every single time. And that's the real million-dollar question, isn't it? What is it exactly that the people marking this are looking for? Well, lucky for us, the official mark scheme tells us precisely what a top-tier answer is.
For abstraction, the perfect answer is just beautiful in its simplicity. It's that the program stores a student's year group instead of their specific age or their date of birth.
And that just perfectly shows what abstraction is all about. I mean, for a sports day, does the program really need to know a student's exact birthday? Of course not. All it needs is their year group to put them in the right category. It removes or abstracts away all that unnecessary detail to focus only on what's essential.
All right, now for decomposition. The mark scheme's answer here is just as clever. The program is split up into different events.
So think about it like this. The programmers didn't try to build one giant monstrous sports day program all at once. No, they decomposed the problem. They probably built one chunk of code to handle the javelin, a completely different chunk for the 100-meter race, and another for the high jump. Each piece is smaller, way simpler, and so much easier to build and test.
Now, I know this might all seem like just a little academic exercise, but I promise you, these two ideas are the absolute bedrock of how all modern technology gets built. This is how we get from a simple idea to a massive global application.
I mean, think about it. Decomposition is what lets huge teams of developers work on the same app. One team handles the login screen, another handles the chat feature. And abstraction, that's what lets a developer use a powerful code library without needing to understand every single line inside it. They just use the simple commands. This is how you build software that actually works and doesn't fall apart. So I'll leave you with this. The next time you open up your favorite app on your phone, just take a second. Try to look at it with these new eyes. How do you think they broke it down into smaller parts? What incredibly complex stuff is being hidden from you behind a simple button? Because once you start seeing it, you'll never look at software the same way again.